Section 3.4 is pretty quick. We're just taking the molecular basis of compounds that we have talked about a little bit ago, and we're applying it now to get a little bit more detailed view of our classification of compounds that we had before. So remember our scheme before where we had matter and pure substances and elements and compounds. Well, now we want to subdivide the elements and the compound side of it to be a little bit more descriptive considering atoms and molecules. So if we look at this in more detail and we're on this pure substances side, we can actually split this up in element-wise into atomic or molecular, and compounds into molecular or ionic. So we look at this in a little bit zoomed in aspect. Any element that's atomic is going to be individual atoms with no bonds whatsoever, and that's a pure elemental substance. Several of the elements on the periodic table also exist as diatomic. Those elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so 7 elements that exist as what are referred to as diatomic molecules when they are all by themselves in nature. Okay, so the molecular elements, these ones, there's a couple others. There's like sulfur and phosphorus actually exist as like S8 and P4, but don't worry so much about those. You do have to have memorized though that these hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are all going to exist diatomically. So that's referred to as a molecular element. So it's still just one type of atom, like oxygen for example, but they exist as oxygen molecules with a bond between them. And this would actually be a covalent bond in this case. Now, molecular compounds exist as discrete individual molecules, and ionic substances have a formula unit, which is basically their empirical formula, or their simplest ratio of the ions, but they exist in a large way as an ongoing sequence of positive, negative, positive, negative, positive, negative, positive, negative ions in a larger structure. Now, when we talk about atomic mass, and we talk about it for molecules, we can just add up the individual elements, masses that make it up. When we talk about the molecular mass for an ionic substance, we actually refer to it as the formula mass, or formula weight, instead of molecular mass, because we're usually talking about just the mass of one formula unit worth of that substance. But that's really the only difference on the atomic scale that we're looking at compared to our previous chart is atomic versus molecular elemental compounds, and molecular, discrete, separate, covalently bonded molecules versus ionic, where we have positive, negative electrostatic attraction, creating extended networks. Sometimes we have both though. If we have sodium hydroxide, we actually have a covalent section that's a shared oxygen and hydrogen together, forming a polyatomic ion. It's called, they have an anion that's OH together, and all together it's a -1 charge attached to a sodium, which has a positive ionic charge. So we have this polyatomic ion attached to a monoatomic ion, and the bond that holds the sodium to the hydroxide is ionic in nature. So the oxygen to the hydrogen is covalent, but the sodium to the hydroxide is ionic. So you've got a space film model, the sodium, ionic bond, covalent bond between hydrogen and oxygen, And then we have a whole sequence of these as a crystal because it's an ionic compound. So we have repeating units of positive and negative